This will be a brief introduction to the sugar and soft drinks lab that you'll be doing coming up pretty soon. Basically in this lab what you'll be doing is taking a look at measuring the percent sugar that you have in soft drinks using two methods, both density and using a hydrometer as a means of measuring density. In looking at this lab, there's some learning objectives we're after, trying to make sure we can do some things that are kind of helpful to us. One is we want to be able to relate density and buoyancy with each other, the ability to be able to float. The second is we want to understand a relationship between sugar concentration and density. And we'll find that as a solution becomes more concentrated in sugar, its density tends to go up. We'll also want to be able to measure the sugar concentration and get to it indirectly in two ways. One is by using direct density measurements, where we just measure the density of the solution. The other one is where we use a hydrometer. You'll also be able to construct a simple hydrometer, sort of like arts and crafts time here, little pieces of paper and lead shot and things like that. You'll calibrate your hydrometer and use it to make measurements of percent sugar. And you'll be able to use Excel to construct calibration plots for both the density and the hydrometer sets of readings. And also use Excel to turn those valuations of calibration data into actual percent sugars. So that's kind of what we're looking for in this particular lab. We'll be looking at two methods. One is the direct measurement of density, which is pretty simple. Density is just mass over volume, so if I measure mass and volume I can find that directly. The other one is using something called a hydrometer, which is used in different places, sometimes in batteries in cars, all sorts of different applications for hydrometers that measure density. And then that, in this case, will relate back to our percent sugar. The density, as you hopefully recall, is just the mass divided by a volume. What happens in the case of a sugar solution, an aqueous sugar solution, is by put more sugar into it, I'm going to have my density go up. And so we'll be monitoring how that changes and tracking that back to what is my percent sugar in a solution. In this direct measurement, alright, I had a slide stuck in there extra. That's alright. What we're going to do is record the mass of an empty 10 milliliter graduated cylinder. You have one in your drawer. You'll take it, put it on the balance, get the mass of it. And then what we'll do is take and put 10 milliliters, it might be another volume of that drink, it could be 8 or 9 or whatever, just make sure you record it well. Volume of the particular soft drink you're working with or fruit juice you're working with in a 10 milliliter graduated cylinder. Measure its volume accurately and then record the mass with the drink in it. Okay, so what we'll be able to do then is figure out the density by how much liquid did I have, what was the mass of my liquid divided by what was the volume of that liquid that we were working with. So the direct measurement of density is a pretty straightforward type of process to carry out. I have some notes here regarding using a graduated cylinder. You've used them a little bit. We haven't talked much about how to do that. Your lab instructor may have done that, hopefully, but it's, how do you actually record data from there? One of the things to keep in mind is you always want to estimate one digit when you're reading a graduated cylinder. We'll see that in just a second. A couple things to note about it is if you look at this first picture here, I've got some liquid in there, graduated cylinder. You can see I'm kind of looking down from below and looking up at it. That's not how you want to read a graduated cylinder. You want to read it as level as you can. You might notice that in this one, that right around here, you've got this line that goes all the way around that graduated cylinder. That's the line to help you make sure that you're going to be even, that you're not suffering from some sort of an angle problem with it. And you can see that those lines aren't even at all. I'd have to move up quite a bit to be able to read this. So this is not how you want to read your graduated cylinder. Another way you don't want to read your graduated cylinder is this, where you read it from up on top. Again, if you look at these lines here, this line goes all the way around that graduated cylinder. When you go to read it, you want it to look like one line, so you can get down much lower in order to read it. And so you don't want that either. What you do want is you want something that looks like this. Now you have to keep in mind that I'm taking these pictures and I'm not that good at it, and I have bad eyes anyhow, so it's kind of an interesting thing. But if I look in here, what I see is I see this meniscus down here. It's a little bit of a low spot in that liquid. That's where I want to read the graduated cylinder. Now in this particular case, what you'll see is it's right about on this line right in here. If you look at the graduations, here's 8, here's 9, and so this looks like 8.2, 8.4, 8.6, 8.8. So if I'm going to read this, I'm going to point out it's right on the line. So now I'm going to write down 8.40 milliliters like I have down here at the bottom. That 0, you're going to say to me that 0 doesn't matter because it doesn't make any difference in my calculator. That's true, but you write it down so that somebody knows that you're using a device that was marked off this well to make that decision about what that digit was. This is where your idea of significant figures comes into play. It's important for the final results you get in any kind of experiment to know how precisely you're able to know that value. Now the hydrometer part comes in, also deals with density. In the hydrometer part, what we see is Greek scientist Archimedes, a long time ago, came up with this idea, and he was working on a deal with the king. The king had given the craftsman a bunch of gold to make a crown. He got the crown back. The king wasn't too sure whether he had all the gold in it or the craftsman kind of slid some other cheaper stuff into it. So Archimedes figured out a way of determining what the density was of the crown. And the story is that once he figured it out, he was so excited, he was in the bathtub, and when he figured it out, and he got so excited he ran down the streets naked yelling, "Eureka, Eureka." I don't know if that's true or not, because obviously I wasn't there. But what he came up with is this, is that an object that's immersed in a fluid, like anything, like even immersed in air, is buoyed up or lifted up by a force that's equal to the weight of the fluid displaced by the object. If you're a physics type person, weight and mass and all this kind of stuff mean things to you. What it means here is basically you have to have as much weight pushing up as you have dragged down. And you get more weight, the more displacement you get inside there. And so the weight of the fluid is related to the mass of the object. And so what you find out then is you can actually figure out something about how dense a fluid is by how much it will lift something up in that process. And a hydrometer is a device that does that. If we look at a sort of figure of a hydrometer here, I've got a couple things on this side. These gray things up here are the hydrometers themselves. Looks like that. The one down here, same hydrometer. And this is the black part is actually a solution that it's in. Excuse me. And in the top solution, what I've got is the hydrometer has the same downward force in each case. It's being pulled down by the force of gravity the same in each case. And the thing that keeps it buoyed up to a certain level is how much the weight of the fluid that's been displaced in there. So if I look in the less dense case, what happens? Well, if this is not as dense down here, if the black is not as dense as what it is down below here, what's going to happen is I have to take and displace more fluid to get myself up to that weight. It's going to sink more. That nearly makes sense, doesn't it? It's going to sink more, not as much stuff pushing up on it. On the other hand, if I look at the more dense case, now I've got more mass down here per volume, and what happens in this case now is he's going to be stuck up higher out of the solution. So if I could just take and measure the heights of the hydrometer, then I'd have some idea of what the density is of these different solutions, and that relates back to my percent sugar. This is really a pretty bad drawing anyway, but because what you'll see in your hydrometer is the whole big bulby part will be down below inside of here, and what you'll have is a little scale up here at the top that we'll use to measure how high it's sticking out. So see this right here, this is a really nice looking hydrometer. This one has melted lead probably in the bottom of it. It has a really nice scale, really well calibrated device. What I want to point out to you is that's not yours. We're going to do something a little different. We're going to have you make your own hydrometer. And so your hydrometer is going to look like this. Okay, so what you see in this one is down the bottom you have lead shot, and up in here you have a scale that you're going to stick in. Now these are those little plastic pipettes you see in the lab. All we do is cut the top off here so you have a little room to work. Take and put the lead in, put the paper in, and this guy will be your hydrometer. And so he looks like that. You can be proud of him. Your hydrometer is unique. Nobody else will have a hydrometer that has the same calibration characteristics that yours does. So you need to make sure you get and keep your calibration data, because you can't go and borrow somebody else's. It won't work that way. So with that in mind, let's take a look at this. I think I pointed out before, as the sugar concentration goes up, so does the density. And the other thing I might point out is that in drinks with more sugar, the hydrometer will float higher out of the drink, as we talked about a couple slides ago. The more dense something is, the higher it's going to float. And the height of the hydrometer, that tip sticking out of it, can be related to percent sugar in a drink if you knew the height it floats in some known concentrations of solutions. So that's what we call a calibration part. We have to take the hydrometer, we have to take the density data that we have, take both of those different sets of data, and relate the measured quantity back to something that we know. And that way we can use it to work in the other direction. So when we talk about the calibration of the hydrometer, here's what we're going to see and the density both is we're going to take measurements of both density and hydrometer height in 5 known sugar percent solutions. They're going to be 0, 4, 6, 8, and 12. If they aren't, don't panic, just write down whatever they are, and we'll use what those are going to be. Second thing, we can take those data and we can plot them as density or as hydrometer height against versus the percent sugar to construct what we call calibration plots. It gives me that relationship, some sort of a mathematical relationship I can use to work in either direction then. And these plots are typically linear. You can see the one down here I've got plotted out. This happens to be hydrometer height along here. Notice this is a hydrometer height, this is the percent sugar. This will be the density for your density data, and this will be the percent sugar. So when you're done with this experiment, you'll have two plots that look like this. One will be the hydrometer height, and one will be the density. Okay, so our calibration work has to do with finding what this relationship is, and then we use that to measure the percent sugar in different types of drinks. So if we continue looking at the calibration data, we're going to plot the calibration data using Excel, which you may or may not be familiar with. If you are familiar with it, you can probably skip through a lot of the next section. I'm going to show you kind of how Excel works. If you're not familiar at all with it, you might take a look at it, realize that you may not get it the first time, but start playing with it a little bit, and software is very forgiving. You cannot destroy it, so you just play with it and kind of figure things out. We'll plot the calibration data using Excel. We'll let Excel do a trend line or linear regression on it. You may have done this with a ruler before. You may have done this with the LabQuest before. We're going to let Excel do it this time to find what the slope and the intercept are for the best straight line through your data points. And if you go back and think, you're really sick of seeing this, y equals mx plus b, m is the slope, b is the intercept. So if you go back to the previous slide and think about what we had back there, we had two straight line equations with which to work. One was the density equals this, looks like that, and the hydrometer height looks like that. And they'll have, keep in mind, they'll have different values of slope and intercept. There's no reason for those to be the same because they're measuring entirely different quantities. So I take a look then over here, and what we're going to do is take a look now at how we use Excel. And before we do that, let me point out one other thing that might be helpful to you. This video is based on using Office 365, which I think is Excel 2013. The computers in the Sarkey's computer lab, well, neither Sarkey's computer lab, are running in Excel 2010, I believe it is. So a little bit different version. But if you get the idea down here, it's pretty easy to find your way around in different versions. It may just be a little bit aggravating once in a while. I don't know if you knew this or not, but you now can actually get your own free copy of Microsoft Office. That should not be a question mark. That should say 365 right there. Just by following the instructions here given below. And there's signs hanging all over the buildings that you can see that. And I'd encourage you to think about doing that because you get at least a whole year's worth of it. And it's the whole suite. That's the whole thing. And so certainly think about taking care of that. But let's go ahead and take a look at this video. I don't know how long it is. It was probably too long, but we'll take a look at it, and we'll come back with a couple more slides to finish out. An idea of that. Some of you may be experts at it already. We'll go ahead and we'll pull it up. And in particular, one we're running here, this is from the Office 365. So it's the Office 2013 package, I believe. Get a opening screen looks like this. Double click on the blank workbook, and there's what my workbook looks like. All the spreadsheet is a way of handling, manipulating numbers, making graphs, charts. It's a very, very powerful type of thing. In this particular experiment, we're going to be taking some data with sugar, and I've got a little bit of hydrometer data I'll look at. You'll have two of these sheets when you get done. You'll have one for density and one for hydrometer as well. But I'm going to come up here, and the way these things are labeled, you'll notice up in here they have A and B and C. So the columns are letters. The rows are going to be the numbers. And so if you want to talk about cell F8, here's F up in here. I come down to here where I'm at the 8, and there's cell F8 showing up right in there. So when we refer to cell numbers, that's pretty much how we do that. I'm going to type in some data that I picked up last spring or sometime or another, and it's calibration data, and it's with hydrometer. So we have a percent sugar where we had a 0, 4, 8, 12, 16% sugar. We measured the heights in our hydrometer, and these are in millimeters, although we don't really care much about what those units are. So I'm going to take it, as I put these numbers in, all I do is type in and hit the enter, and it goes from there. You can cursor around wherever you want to in the screen, and everything's fine. So I'm going to go in here and say this is 0, 4, 8, 12, 16. And the heights I got of that measurements were 6.2, 5.82, 5.05, 4.75, and 4. Okay, now what we're doing with these data is you're going to do two graphs, one for density and one for the hydrometer. We wanted to have this relationship so we know if we know the percent sugar, here's what the height of the hydrometer is floating out of the water. We want to make a calibration plot of those data. We want to show what the hydrometer height looks like as a function of sugar. So when you go and you stick it into your other soft drinks, you can go ahead and you can figure out what the percent's going to be of those percent sugars based on hydrometer height. It's kind of a very common calibration thing for us. We do something we know, find out what this other variable is, and we take that variable and go back to unknown solutions and figure out what they're going to be. A really quick way of making a plot here in Excel, we aren't going to go into great details in this, we'll just go through the guts of getting it done. If I take and I just highlight that section there, my X and my Y values, it will take and make a plot for me in that XY direction. So it's going to think that 0, 4, 8, 12, and 16 are going to be our horizontal axis, our X-axis, and that's certainly what we want it to be, and then the sugar will be the other one. There are ways of changing them around and taking series from all over the place. We're not going to mess with that. What I want to do now is insert a graph. And it's fairly easy. I come up to Insert, and I come over here to where it says Charts. I call them Charts, and virtually always in these sciences, in chemistry at least, you're virtually always going to be looking at taking a scatter plot, it's called. And a scatter plot, it pays attention to what the numerical values are in both the X and Y axes. So take a scatter plot, and don't make it all complicated with null lines and all that, and just click on this scatter one up there. And now what you see is, there are my points, all plotted out. You might remember you did this by hand possibly before. It took a little while to do that. We might have done them in the LabQuest before as well. That works out pretty well too. But there's what my chart looks like. Now it's not a very pretty looking chart yet because I don't have a good title on it. I don't have axes labels on it. In the different versions of Excel, this is the newer one, and so it's a little bit different than what the ones are you'll see in the computer lab. But you can kind of follow along, I think, as we go. In the 2007 and the 10, in the older version, the computer lab, up here you'll have a tab that's called Layout. If you click on that, it'll have a place where it'll say chart heading, chart title, axis titles, whatever. It'll say that kind of stuff up there. In this particular version, if I just click on a plus sign, it lets me put those things in. So I can go and put an axis title on here, and that looks pretty good. And I can come up here and say, okay, what do I want to call these things? Well, up here on the vertical axis, that's my percent sugar. So I'll just type, no it's not, it's my height of my hydrometer. So I'll just type in height of hydrometer, get rid of all those other letters I have in there, and it looks like that. And then I'll come down here to where I have the axis title on the bottom, the X-axis, and this is where my percent sugar is. And at the top of it I may say something like, make a title that's not just telling you exactly what it looks like. We could say this is the hydrometer calibration plot. That sounds really official. That sounds good. Looks like this. And so we go along there. And the reason we do the calibration plot is we want to know what the relationship is between the height of the hydrometer, how high it's floating out of the water, compared to the percent sugar in the solution. These are our calibration ones. We knew what these concentrations were, and our plot looks like this. It looks kind of linear. It's not perfectly linear because, well, I took the data, but that's what data does. It doesn't always do what you'd like it to do. But it's fairly linear, and so I'm going to think it's a straight line. And what I can do is add a straight line into it and say we come up with the best line equation. So if I come up here and I right-click on any one of these points, I'm going to take and right-click on this point right here. Down toward the bottom, you'll see where it says Add Trend Line. So all I have to do is click on Add Trend Line. Boom. And I get this little thing showing up. I think it looks linear, so I'm going to leave this as linear. I could change it to exponential over here on the right, or logarithmic, or polynomial, all sorts of things you can play with. And what we'll do is we want to make sure we see the equation. It doesn't do us any good. Sorry, it doesn't do us any good to do a straight line equation and not know what the slope and the intercept are. So I'm going to go ahead here and click on Display Equation on Chart, and there it is. And I'm also going to display the R squared. That's a measure of how good of a fit it is. If it's a 1.0, it's a perfectly good fit. If it's a 0, there's no point in even trying to say that was a straight line. So this is a pretty good looking set of data. And so when I come up and look at this box, I can move this box wherever I want to. If you can't read it, you can move to different places on the chart. You just drag along. I'm dragging with my finger, by the way, right now because my mouse died. He's back. And so my plot looks something like that, and it gives me the slope and the intercept. Okay, so that's my hydrometer calibration plot. You're going to do a similar one for density as well. Now, what I'd like to do is I want to use this information to go back and figure out what the percent sugars are in the various soft drinks. So I kind of worked ahead on this a little bit, and we'll see if it's still there. And I'm going to take and paste in the values that I measured for the height. So these are the hydrometer heights up in here. They look like that, okay? Now, what we're going to do is that line, that y equals minus 0.1368x plus 6.258 is a line that gives us the linear relationship between the height of the hydrometer and the percent sugar. We want to solve this for percent sugar. As you know from looking at the PowerPoint and actually your straight line abilities, if I want to solve this for percent sugar, what I want to do is take my y value here. I want to subtract that 6.258 from it, and then I want to divide it by the slope. That will leave my x all by itself. What I'm going to go over here and do is I'm going to just pick a box out. It doesn't matter which one. I'm going to type those values in here so I have them to work with. And so I'm going to type in the slope and intercept so I know where they are. And when I come up to here in the slope, it was negative 0.1368. If your slope comes out negative, let it come out negative, that's fine. If it's positive, put positive. But make sure you get the sign right. By the way, depending on how you built your hydrometer, you and a buddy may have different slopes. One may be positive, one may be negative. It depends entirely on what direction you stick that little paper slip thing in, so don't worry about it. You have built the world's only hydrometer that's like yours, so your calibration data are the only ones that matter. Now what we want to do is we want to come over here and we want to find the percent sugar. And so instead of having to do it by hand, which would seem easy at first but actually gets pretty tedious, and so we're going to do it this way. We want to take whatever our height is, whatever our hydrometer height is, and we want to subtract the intercept. We want to divide that by the slope. So here's what we're going to do. The hydrometer height is over here in B. So if I look at 7 up, the hydrometer height is here where it says 4.61. But I'm not going to type in 4.61. I'm going to tell it I'm putting in a formula. My formula is going to be this. I'm going to put an equal sign to tell it the formula. I'll put a parentheses in there, and now that hydrometer height for 7 up is in the cell called B13. So I'm going to call him B13. And then I want to subtract from him the intercept, which I put up here in B10. The trick here is be careful because we're going to take this and just copy this formula down and do it all at once. We want the B13 to change, which it will. It'll go to B14, B15, B16, but we don't want the B10 to change. So what we'll do to tell it not to change, we'll kind of overkill with this. So you put a dollar sign in front of the B and a dollar sign in front of the 10, then it will stay the same all the way down when I copy it. Now I want to divide this by the slope. Well, the slope is up there in B9, so I'm going to do the same thing, dollar sign B, dollar sign 9, and I hit the enter, and there's my percent sugar for 7 up. You think, well, that's a lot of work, but watch this now. What I can do with it, and there's a couple different ways of doing this. If I come down, oh, maybe not in this version, come down to here and I right click on that, and I'm going to copy that cell. I'll come up here, copy, and then I'm going to take it, and I'm going to drag it all the way down. Pardon me, my mouse, there's my mouse again. It's a great little computer, except once in a while the mouse just copy that all the way down. And I'm going to paste in. Oh, I may not have gotten it in there. I think I forgot to copy it. I'm going to take this guy here. I'm going to copy him. And I'm going to drag him down to here. Right click again. I'm going to paste him. And I want to paste in that first box. I want to paste the actual formula down. And you see what I did there. I pasted the formula, and all of a sudden I have the percent sugars for all of those sodas all the way down without having to recalculate. Notice what happens in the formula. It's kind of fun to look at the formula. Let me get out of here. I'll just escape. Look in here. That's B14 minus B10 over B9. This is B15 minus B10 over B9. This is B16 minus B10 over B9. This is B7, so on and so on. By using the dollar signs, I fix it to one cell all the time, no matter where I copy it. By leaving them off, it just automatically adjusts. When I put in B13 minus B10 over B9, what it's really saying is take the cell that's right over to the left of me, subtract the cell that's up in B10, and divide by B9. And it carries that all the way around. Very, very, very powerful types of materials. If you want to print a picture of just a plot or just a copy of the plot, just click on the plot. And when you go up to File, Print, it'll just show you the plot. You can print just the plot if you want to. You can drag it over the whole thing. You can print all these values over here as well. Just drag it over that. And the best way to do that probably is just drag over the whole thing like this, like that, and just tell it to print. your selection, inactive shades, print my selection, it'll print just those values. And you can do all sorts of things to pretty that up. But that's the basics of how this works. Now you're going to do both a hydrometer and a density reading. And I think one of the things you can do is, this is pretty neat, worked pretty well and all, instead of having to make a new Excel sheet entirely, you could actually take pretty well and just do this. If I take and I right click on my sheet tab down here, I can tell it to move it or copy it. I'm going to tell it to copy this thing. So I'll just move it out here to the end. I want to create a copy of it. Now I've got this, and now there's not a whole lot of difference between what we did with hydrometer and what we do with the density. And so what I can do out here is I can take this thing and come up, and where my percent sugar is, I can change this out to percent to density. Put in my density values here and here and here and here and here. My plot will automatically adjust. I'll automatically get my new slope and intercept. I think, check and make sure it changes. And all my formulas will be intact. So it actually goes pretty rapidly at that point. I thought I'd just give you this rundown on Excel and how to use it. Certainly it'll be a little bit different if you're using 2010. You'll have things like layout tabs up here, but the right click for the trend line, all the formula writing, everything else is going to be pretty much the same. So I hope that helps. So hopefully that gives you some idea as to how Excel works. And just last couple slides, just again to emphasize what we're really up to is we have these two straight line equations. The calibration work gives us the slopes and the intercepts for those equations. Remember, those will be different values whether you're looking at density or whether you're looking at the hydrometer. You're able to go back in and use the equations to figure out the percent sugar based on what we have down below here, just rearranging a straight line equation. So it actually works out, it usually works out pretty well, and you'll see some differences in different types of drinks as you go through. Just the last procedural note, just to make sure you're really clear about this, all those different drinks you have, only 5 points go on each calibration plot. The known concentrations, 0, 4, 8, 12, 16, or whatever those concentrations are you're given, those are your known concentrations. Those are the only ones that show up in a graph at all. One set for the hydrometer, one set for the density. The others are all just calculated like we had down below in the table. Certainly hope this helps, and good luck with the experiment.